everybody else is. I gotta do something to keep myself awake if.
Yeah, how are you doing? Good. Your friends were here today and so on. Yeah, they're visiting the project. Okay.
All right. Let's start off with. We'll start off talking about the paper for a few minutes. I think the paper was linked list versus arrays.
Yeah.
So it's going to be mostly review. We talked about that quite a bit last class, right?
Yeah.
Just
Plus extra. You have to find out from internet sources. So additional read up.
All right. This is the class. All right, so for the report, write a 2 to 3 page paper discussing the advantages and disadvantage of disadvantaged. Man, that's pretty crappy English. Did you write this, Habib?
Yeah. I just copy paste that one.
Here, let me fix this a little bit.
Yeah, the report just say copy paste from the sources.
Write a 2 to 3 page paper discussing the advantages and disadvantages of linked lists versus arrays. Note that linked lists are not the upgrade to arrays. These two structures solve different problems. Discuss when each would be the right tool for the job. Okay. All right, so, just I'll kind of gloss over it quickly. So we talked about arrays being fast, right? So the thing that we want to keep in mind when you think about arrays is arrays are fast but memory inefficient. Linked lists are slow but memory efficient. Okay, that's kind of your advantages and disadvantages of the two. So we really want to think about linked lists as not necessarily being the upgrade to arrays, but you want to use them when it's the right tool for the job. So for instance, your homework assignment that we'll go over here in a few minutes was a problem that really could only be solved using linked lists. Because if I'm having you support an arbitrary size integer, arbitrary means as big as possible, right? So it doesn't matter, it can be infinite until you run out of memory. So the only limiting factor for the size of your huge integer, that was what we were writing, huge integer for addition, right? The only limiting factor for huge integer is really size of integer, or I'm sorry, size of memory. When you ran out of memory, you could no longer store a bigger number. But, that was the limiting force as opposed to the data structure itself, as opposed to traditional integers, which are 32 bits. So you can't fit a number in there bigger than 4 billion. Really, you can't fit a number bigger than 2 billion because it's a signed 32-bit number, negative 2 billion to positive 2 billion. Okay, so an array really wouldn't be an adequate solution to this arbitrary size integer that we talked about, this huge integer, because you have to at some point decide this is the size of my array, right? And can that hold an arbitrary size value? No, it can only hold a value that has this many digits in it, maximum. What if you want this many digits in it? So really, arrays, as good as they might be from a performance perspective and things like that, really were not sufficient for solving that particular problem. Okay? So just from what you guys wrote, what's some examples of problems where an array is the right tool for the job versus linked lists when they're the right tool for the job? Did we come up with any examples outside of the homework assignment, which we're talking about linked lists, so obviously the homework assignment should, be benefited by linked lists. Did you come up with any other examples of kind of a generalistic rule of thumb for when linked lists are the right tool for the job versus arrays? So what did we say in our paper? We got a lively crowd here. That's kind of slow dance music.
Accessing memory with the arrays would be much easier because you have a build-up memory.
For what kind of problems?
For the if we required many times to access like a specific type of memory information,
Oh, like searching.
yeah,
Okay, so if we're solving a problem where
and
the kind of the main focus is searching,
yeah,
where we're
and
searching
then,
a lot often, we're
Yeah.
looking through the data often, an array makes more sense. Even though it's memory inefficient, we'll gain a lot of performance by having it implemented in arrays. So if your main goal with your data is to search it, we care less about its footprint. Like, go ahead and be wasteful about memory, but let me do fast searching.
Yep.
Okay, and then the alternate side of that is if you just need to store a lot of data, but you really don't need to query it very often, then a linked list maybe
Yeah,
makes more
yeah.
sense. Okay, I think those are fair statements. Okay, anything else? Just as a quick reminder, I sent out an email when I, hopefully everybody got it, that I reduced the size of the program, the homework assignment. I only had you do addition, not addition and multiplication. I think multiplication would have been, I'm guessing addition was all you could handle as it was, right? It was probably a pretty hard problem to solve. So addition and multiplication would have been a knockout punch probably. But I also reminded you to do the self-evaluation because I, mostly expect probably 75 or 80% of the class probably did not get the programming assignment working. So make sure if you didn't already do so sometime tonight, go in and if you go under lessons in here, I have a little blurb. It says homework instructions and self-assessment. There's just these 4 questions. Make sure you answer those 4 questions and paste it into the little text box with your solution. Just that gives me kind of the almost like the color commentary on what your experience was with the homework assignment, where you struggled, what's working, what's not working, and kind of what your mindset was. Like, I didn't get this working, but this is what I was trying to do. Something like that kind of gives me an opportunity to let you explain in non-programming terms what you were, where your struggles were and what you were trying to do, so I can try to give you some partial credit. Make sense? Where if you just turned in a pile of slop with no commentary, then, I can't really give you very many points. So make sure you fill that in if you didn't already do so. Inside of here, I give you this warning that if you don't do this, it's an automatic 0. So this is your easy slide for the first week. If you didn't do this, make sure you go back and submit it sometime tonight or early in the day tomorrow or something like that. And just get it in there with your homework. You won't be late or anything. Just make sure it's in there.
Yeah, I did not do this one, so I will receive my tomorrow.
Okay, that's fine. Yeah, I probably won't look at it until thinking probably Wednesday morning is when I'll probably grade these. So make sure your self-assessment is in there by 8 a.m. on Wednesday morning. Let's go that route.
If I will do it for the report and for the homework for the both.
Yeah, for both. It's more important you do it for the homework. Do it for both just so for consistency perspective, but obviously I think most of you probably can write the papers and say, I think I answered all the questions, blah, blah, blah. So it's more of a,
So you we have to write at the end of the report or just at the beginning?
It doesn't matter. I would say just paste it in with when you submit the homework.
Yeah.
When you go in here and you actually, submit your homework, you have this text box here. Just paste it in here.
Okay.
That makes sense? All right. Any other questions about that?
Nope.
All right. So that's your opportunity to elaborate and beg me for a better grade than you maybe deserve. Make sense?
Yep.
So, okay. So let's talk about the homework assignment then. Out of curiosity, how many of you got it working? One person? 1.35 people? You said you tried?
It's working, yeah.
It is working. Okay. So 2? Okay, so half the class. How many of you completely bombed out on it? Like it was impossible and you spent 15 hours on it? I get a text message from him in the middle of the night. All right, well, let's see if I can solve the problem. Let me read what the problem is first. All right, so using your own linked list implementation, which I provided, implement a class called huge integer that represents arbitrary sized integers and supports addition only. Okay, I took away the multiplication requirement. I think it would just was more punishing than I think it needed to be. Addition only. You may only use the tools we have introduced in class and may not use Java's big integer class. This would have been pretty easy if you could use Java's big integer class.
That's the way.
2 lines of
That's
code.
the tool.
Done.
Yeah.
Okay.
You
So-
don't want it, as
Well,
usual.
Let's see. So we're going to come in here, and this is 537.
Okay.
So we're going to create a new class called huge integer. All right. And we already have our linked list class here that we wrote last time. And this is the same code that I supplied you as a starting point. And then we want our driver. Okay. So this is what we have thus far as your starting point. So for huge integers, we want these guys to represent arbitrary size integers. Okay, so integers of any size. So perhaps the easiest way to take this in, and this is how big integer does it, is it receives the number as a string and then turns it into the data structure behind the scenes. In this case, we'll do it as a linked list. Now our linked list here has a bunch of nodes in it, where each node currently holds an integer as a payload. Make sense? So our first step is going to be, let's create a huge integer class by passing it a string, like the string, I want to be able to do something like this. Huge integer hi is equal to new huge integer 1, 2, 3, 4, 5, 6. So 123,456. I like to create it this way, but behind the scenes, I need to get this guy stored as individual digits inside of a linked list. So what we'd like to do is we'd like to create a structure that kind of looks like this. Just like I warned you last class, I'm really trying to emphasize this idea of drawing pictures. If you struggled in this homework assignment and you didn't draw pictures, it's your own fault. Because I certainly strongly encouraged you to draw pictures. Okay. So we'd like to build a structure that looks kind of like this. Take our string, 1, 2, 3, 4, 5, 6, something that looks like that, and break it into a linked list filled up with nodes where each node holds one of the digits. Make sense? Okay, so this is what we want to create. Now the good news is we already have the linked list structure to create this for us. Correct? So we can go through this string, extract each of the integers. And what would we do with that integer? We would add it to our linked list. Make sense? So let's start off with just that. Let's build our constructor, have our constructor take in a string, piece out the string, build a linked list from it, and then display the linked list, showing that it's legit. Okay?
I can teach this part of class for you.
You can do this one? You want to?
I'm the one getting paid for this.
Either am I. Go figure. Okay. Well, I got confused. Okay. I think I know where I am now. So inside a huge integer, we're going to keep track of a linked list. So we're going to have a private linked list. Maybe we call this guy the number. Okay. Then we'll have our constructor. Our constructor will take in a string num as a parameter. And we want to go through num taking, so num would look something like this when we build this guy. It's going to be a string representing our number. We now need to take that number and put it into a linked list so that we can work with it. Make sense? All right. So first thing is we need to make our linked list. We need to initialize our linked list. So we're going to say the number is equal to new linked list. Okay, that's using our linked list constructor, this guy right here. Okay. There we go. Now we need to go through our string and add each element to our linked list. So just for right now, I'm going to say system.println num.charat I. So all this constructor does right now is it initializes our linked list, but it goes through our string and prints out each individual character of our string, one character per line. Just kind of showing us what we're working with here. So the output for this guy right now should be 1, and then the next line 2, the next line 3, the next line 4, the next line 5, then the next line 6. Okay, because that's the contents of our string. But our string is currently holding a bunch of chars. So I'll go ahead and I'll run this. So now I can build my huge integer inside main. I passed it my string. That's going to come to the constructor of huge integer right here. And it's just going to go through and print out all the characters from that string. Nothing fancy. And there's our 1, 2, 3, 4, 5, 6. But each of these guys is a char. In order to store to my linked list, I need to get it into an integer. So if I have because I don't want the integer version of 123,456. I want the integer version of 1. Then I want the integer version of 2. Then I want the integer version of 3. Then 4, then 5, then 6, because those are the things I want to load into my linked list. Make sense? Okay. So from 535, we learned about the integer.parseInt method for converting a converting a string into a int. So num.charat I is a char. Let me just get rid of all this here. This guy right here is a char. If I want to make that guy a string, I concatenate it onto the empty string. Now it's a string. Make sense? And what do I want to do with that string? Integer.parseInt that string. That will give me the int version of that string representation of that single char. So if I pass this guy the char 1, this would boil down to the int 1. If I pass it the char 2, it would give me the int 2. Because it would take, let me just show you what it ultimately would do. If I had the char 1 that looks like that, and I concatenated that onto the empty string, I would get the string 1. Make sense? And then integer.parseInt of that guy would give me the number 1. So that's what I'm doing in this one line here. I'm gluing these guys together, giving me that, then I'm parsing the integer out of that. Okay? So very, very, very powerful line of code here. If you remember back from 535, your first assignment was like process expression, I think, something like that, where you had to go through and you did not have access to parseInt. You had to build your own to make this work. Okay, but now we have access to this power tool. All right. And what am I going to do with this integer? I want to add it to my linked list. So we're going to say the number dot add end, what value? Integer dot parse int, this guy. That makes sense? So we're going to go through every character in our string, turn each of those characters into their equivalent integer, and then add that integer to the end of our linked list. Go ahead.
I did it the other way where you started at 0 and then less than num length and you started at the add end. I did add front and then I started at the length minus.
Yeah, that's
one
fine.
and went down.
Yep. So in the end here, I should be able to say the number dot display, and it should show me a 1 linked to a 2, linked to a 3, linked to a 4, linked to a 5, linked to a 6. All those things got added to my linked list correctly. A 1 linked to a 2, linked to a 3, linked to a 4, linked to a 5, linked to a 6. So I've loaded up my linked list with the correct values. Make sense so far? Okay, so that probably should have been your starting point. Everybody see the screen okay? Or you want to turn the front lights off? We're good? All right. Frankly, if you turn them off, I might nap. So, but I would give you the opportunity to do whatever makes you happy.
Yeah.
I'm only like partially kidding too. I did drink some coffee on my
I
way
did
over
too.
here. Like specifically, I brewed caffeinated coffee. So I usually drink decaf. So I'm all right. Where am I? Oh, okay, got it. So we can say that our linked list now is properly filled up. Correct? Now we'll go ahead and we're going to go ahead and write a public string toString method. Actually, I'm not going to do that. I'm just going to write a display method for my big integer. And this guy's just going to call this dot the number dot display. So we just taught our huge integers to display themselves in terms of the linked list that they wrap. So back out of here at driver, we create our huge integer, then we could say hi.display. And we should see the internal representation of that number now. Okay? Now, the assignment was if I have two numbers, hi1, huge integer hi2, and let me just make these smaller numbers for right now, if you will allow me. Here. We'll do 65 and 47. We'll tell hi1 to display himself, hi2 to display himself. And then we see we have the first one is a linked list with a 6 linked to a 5 linked to nothing. The second one is a 47 with a 4 linked to a 7 linked to a nothing. We want to add these two numbers together and giving us a result that is a huge integer. And the result should be 65 plus 47 is what? 112. So my output should be 1 linked to a 1 linked to a 2 inside of a big integer, or inside of a huge integer, sorry. Make sense what we're supposed to do here? So, now we need to go and learn how to do simple math, simple addition. So we have 65 and 47 as our example. So I'm going to go back over here. Actually, let me just steal the size from here. So 65 and 47. All right? And we're adding these guys together. To add them together, what did we do? Well, we take 7 plus 5. 7 plus 5 is what? 12. So what do we record down here? I don't put a 12 down here. I carry.
Oh, you want to put
Two.
2?
2, carry the 1, right? Here, we'll draw a nice little line here. All right, so we have a 2, and then we have a carry bit. So something else came up here. We carried the 1, correct? Now we take the 4 plus the 6 plus the 1. 6 plus 4 is 10, plus 1 is 11, so we record the 1, and then we carry the 1.
Okay.
0 plus 1 is 1. And that's our final answer. That make sense? That's how we do addition. Probably haven't done it in a while, right? We just plug it into the calculator, it does it. We need to mimic this. So we need to take, if we treat both of these as being a linked list, we need to take this element of our linked list and this element of our linked list, add them together, adding the result to the end of our linked list, but also keeping track of a carry bit. Does that make sense? So we have to have all these things going on to make this work. So this isn't complicated stuff, but we do need to think about it, right? So if this is a linked list, just pretend like there's links between it. We need to go all the way to the end of our first linked list, correct? And do what with it? Take the end of the first number, the end of the second number, get those values there, add them together, and add it to the end of my answer. This guy right here is a new huge integer, but it's a linked list. Does that make sense? So it's going to be wrapped around a linked list. So I'll have my 2. Now, how do we build huge integers? We build huge integers using strings, correct? Okay, so the very first thing we want to do here is we want to explore getting to the very end of this guy, the very end of this guy, and getting this 2 with the carry bit. So we want to see if we can make our program output a 2 and then output the 1 that carried, proving that one mechanic. And that's the same mechanic we're going to keep employing over and over again, right? Okay. So we'll go back into our huge integer. We're going to add a public huge integer add method that takes a huge integer as a parameter, and it adds this guy to the huge integer. This guy is an instance of huge integer. So it's this guy, whoever called the add method. We're going to add him to the huge integer. All right, now, how do we do this? We first need to be able to access the last bucket of our huge integer. Well, how are we going to do that? Right now, just for right now, I'm going to return null here just so our code works. Right now, I've built 2 huge integers. One is a 65, one is a 47. We've printed them out, proving that it worked. We need to access the 5 and the 7 and add them together, giving us a 12. And we know part of our result is going to be the 2. And then we know we need a carry bit. Make sense? So inside of add, we know we're going to have an integer for carry. And we'll start this guy off at 0, because initially we have no carry, correct? We'll always add carry to it, but carry will start off as 0. Okay, just like we did here. Could we not have said that the first time through, that we did have a carry bit, it was just 0. And we took 7 plus 5 plus carry, giving us 12 with a 1 carry, a 2 with a carry of 1. Does that make sense?
Yep.
Okay, so, by having that integer for carry here and initializing it to 0, it doesn't break anything. And that allows us to always have a consistent way. So we're going to take this bucket plus the current value of carry to give us this number and the new value of carry. Okay? So, we need to get access to the last elements in our linked list. Let's go to our linked list. Now, I gave you a mostly complete implementation of linked list, with one exception. We can add things to it, we can remove things from it. But, could we get something at a particular bucket? I don't know that we wrote that.
Yeah, there's get.
We did write get?
There was a get bucket.
No, there was an add at index.
Yeah.
There's no get.
Okay, so should be a simple method. It's just like remove at index, right? Except we're not actually removing it. Make sense? We're not actually going to remove it. We just want to get that value. So we're going to write another method in here instead of linked list. Public, we'll have it return a node for right now. Public node get int index. Now, the easiest way for us to implement this would be to call remove at index, then add it at index, keeping the value we just removed. That make sense? That would be pretty inefficient because we're walking the list multiple times, but that would be the easiest way to do this. So we would say something like node temp is equal to this dot remove at index. So now it's actually left the list, correct? Then we'll say this dot add at index. Do we have a value? We'd have to extract the value out of it. Oh, good. So this isn't as easy as it looks. That's fine. I want to do it the other way anyways. So we need to walk through our list to bucket index, getting that value. And we can do all the same crap that we did inside of remove at index, where we check to see if the index is less than 0, linked list out of bounds exception, blah, blah, blah. So I'm actually going to steal most of this code. Most of the stuff we did in remove at index, I'm going to take. We'll paste it into get. Now, since get can possibly cause a problem, we need to say this guy throws an exception, because that's what happens right here. So if the index was an out of bounds index, then we'll throw the exception. Else, if the index is equal to 0, we'll return head. Notice we did not remove it. We just gave them the front of the list. If index is equal to the length minus 1, actually, we don't even need to treat these as special cases. We can just do this. If it's not out of bounds, that means it is a legal position, correct? Therefore, here's the node we're going to return. We'll start off at head. We'll spin through I equals 0, I is less than index, I plus plus. Traverse node each time. Then ultimately, return node to return. So it's either out of bounds or let's just start at the head, walk the list until we get to the right place, and then return it. Notice again, we're not removing it. That make sense? And we could test this real quick and make sure this guy works. Let's just quickly look at node. Does a node know how to display itself? It does. So what we'll do inside of let's just take the display for our huge integer. we'll just rewrite this method real quick just to go through and prove that we can get each value. So for int I is equal to 0, I is less than this dot the number dot length. That's the number of elements that are in the list. I plus plus. And then we'll say this dot the number dot get I dot display. So this dot the number dot get I is a node, and we'll tell that node to display itself. This should show us going through that entire list. Now, notice this guy screaming, saying, hey, this guy possibly throws a exception, so we need to do something about that. So we'll just go ahead and let it wrap it in a try catch. Actually, do we have driver throwing exception? We do. So we'll take the easy way out there. So display, we'll throw an exception. We'll go through for every element inside of our linked list. Let's get each node and display it. This removes nothing from our linked list. We can prove that by, at the very end here, after we've gotten all the values from our linked list, we'll go ahead and display the entire linked list again, proving that nothing was actually removed. So in this case, what should we see in driver? We should see a 6. Well, for HI1, we should see a 6, then a 5, 2 separate lines, then the 6 linked to the 5. For this guy, we should see a 4, then a 7, 2 separate lines, then a 4 linked to a 7. Okay? So this proves that our get method is working. We just go to a certain index, return the node at that index, and now we can do something with it. All right. That makes sense? Now, if the length is 2, which both of our linked lists will have, right? In our example here, legal buckets are 0 to 1. That make sense? Now, we want to go to the end of each of those numbers. So we need to keep track of the position of those two numbers. So, actually, this is a display. Here is in our add method. So, our add method is going to be, we're going to keep track of 2 different variables. One variable is going to be our counter that keeps track of where the current end of this number is. So we'll call this guy curpos1 just for this current example. So this is 0, this is 1. We'll call this guy curpos2. He'll also be a 1. Now understand that if this guy was a little bit bigger number, now this is 0, 1, 2, 3, curpos2 would be 3. That make sense? So if one of our numbers was not the same size as the other number, keeping track of the current bucket we're looking at is important. Because in this case, we're going to take 5 plus the 7, that is the element from this list at curpos1, and add to it the element from this list at curpos2. Do the math, then curpos1 minus minus, this guy will become a 0, curpos2 minus minus. Now we'll be looking at these two numbers. Make sense? Why we need to have those 2 separate counters? Okay, so we'll say int curpos1, and we're going to say that guy is this guy's last bucket. And how do we get that? We're going to say this dot the number dot length minus 1. Int curpos2 is equal to hi dot the number dot length minus 1. And even though hi internally has a private variable called the number, notice that this field is private, we can access it here because we are inside of the huge integer class. Okay? So curpos1 will be the calling huge integers length of their linked list minus 1. And curpos2 will be the guy we passed in, his linked list's length minus 1. Okay? So if we go back to our little example here, let's keep it our simple where the numbers are the same length. Why is that so much bigger? There we go. This guy right here is H1. This guy right here is this. That make sense? Okay, so this guy is the instance of huge integer that called the add method. This guy is the parameter that was passed to that add method. Okay, so when we ask for this is the number dot length, we're going to get the length of this guy's linked list. When we ask for hi's the number dot length, we're going to ask for the parameter that was passed in, his linked list's length. Make sense? Okay, there's curpos1, there's curpos2. So they both tell us what numbers we're currently adding together. So we need to get those two nodes. So let's create a couple of temporary variables. Node, curnode1, node, curnode2. And we want curnode1 to be the node that lives at position curpos1 in this guy. Okay, we're just doing this for those very first numbers. Our goal right now is to add our 7 to our 5, giving us a 2 and a 1 for our carry. We just want to do that one little part. Then we'll build it into an algorithm that repeats. Okay? Again, baby steps. Draw pictures, baby steps, all hard problems are made up of a bunch of easy parts. So curnode1 will be equal to this dot the number dot get curpos1. Oh, we need to make this guy throws an exception, since we could possibly have a out of bounds exception from the get method. Actually, it would probably be good manners in this case to put all this inside of a try catch. For right now, I'll just not do anything. The reason I say good manners is if we had this guy throw an exception, then anybody who tried to call our add method would then have to, we're putting it on them to deal with it. We're saying, hey, it's inconvenient to use our add method because he throws an exception, so it might be more trouble than he's worth. So we'll just deal with it ourselves. So we'll try to do all this crap and catch the exception if it happens. So we're going to say node curnode1 is equal to the node that lives in this guy's the number get curpos1. Curnode2 is equal to hi dot the number dot get curpos2. Okay, those are our two nodes that we want to get. Now we can prove that we got the right nodes there by saying, let's just do a curnode1 dot display, curnode2 dot display. So if these are our two numbers, if this is this and this is h1, and we get the last element of each of these, we should see it display a 5, then we should see it display a 7. Make sense? All right, so let's go ahead and run this. We're going to go out to driver. We need to say hi1 dot add hi2. We won't do anything with the value, but right now, inside of this add method, hi1 will be this. hi2 will be hi. Make sense? And we should see a 5, then a 7. This is cur pos 1. All right, this is cur node 1. This is cur node 2. Okay? There's our 5 and our 7. Okay, so we have those two values. Now we need to be able to get the payload from those. So we can actually do math with those numbers. So we're going to go to node. Node already has a method that lets me extract the payload. Okay? And just to prove that that's the case, instead of telling our nodes to display themselves, we're going to say system.out.println cur node1.get payload. And then we'll also print out cur node2.get payload. Should be the exact same output as we had a second ago, except the way we got that output is a little different. We actually retrieved both nodes and asked each of those nodes to give us the integer that they hold. Okay, same output, 5 and 7. All right, now what do we want to do with those payloads? Well, we want to add them together. And we want to record the result. So when I add a 5 to a 7, I should get a 12. So all I did is I printed out, take cur node 1, get his payload, and add to it cur node 2's payload. There's our 12. Now, we want to get that 2 and the 1 separate. How do we do that?
Didn't we just do that already?
Well, I need to do it programmatically. Right now, it's just printing out a 12.
Yeah, but we just take the thing up there, except it was just that thing, you know?
Well, if I have the number 12, how do I figure out that the carry should be a 1? Why is the carry a 1?
This is the thing in bucket. It's the string is more than one bucket, and so it's the thing in the first bucket.
Don't even worry about programming right now.
Oh.
If I just give you the integer 12, and we're going back to math here, why is it that I don't just write a 12 right here?
Because
It's not allowed, right? That's why. This breaks math.
Yep.
Okay? So if I have a number that's greater than 9,
greater than, yeah.
if I have a number that's greater than 9, I have to do something to it. What's the biggest number we could have here?
9.
No, I mean, if I take this number and I add it to this number, what's the biggest possible number we could have if we're doing decimal
That is the 9.
math? So each of these numbers could be 9, right?
Uh,
Legal digits in decimal are 0 through 9. So worst case scenario, this is a 9, this is a 9. 9 plus 9 is 18.
8.
And what's 18? 18 is 8
8.
with remainder
1.
1. Okay? So if the sum is greater than 9, or you could say it's greater than or equal to 10, what do? You have a carry of 1, and your sum is actually whatever it used to be minus 10. That make sense? So we'll have a carry bit of 1, and we'll have a answer of 12 minus 10, which is 2. So we'll have an int called curval. and we'll set curval equal to this math, adding those two guys together. Okay, then we'll ask the question, if curval is greater than 9, if that's a true statement, then what are we going to do? We're going to set carry equal to 1, and we'll set curval equal to whatever curval currently is minus 10.
Okay.
Does that make sense? Then we're going to print out curval. We'll also print out carry. So we should get E2 carry the 1. There's our 2, carry the 1. Here, I'll take away this little system out that print in here. Okay? So the answer is 2, carry the 1. Now, just to make sure this is working, let's give ourselves a little bit of a different scenario out in driver. So why don't we say this is 63 and 42. This should be 5, carry 0. There's our 5, carry 0. Okay? So let's switch it back to what it was before. 2 and 1. Now, we're not quite doing our math correctly yet. Remember back over here I said we should always add in our carry bit. That way we're doing the same math here as we're doing here as we're doing here. Does that make sense?
Okay.
So that means I need to come in here, and curval isn't just cur node 1 get payload plus cur node 2 that get payload, it's also plus carry. Does that make sense? But the first time through, carry is 0. So it won't break. Math still works. But we're still always including carry in our math. Okay? Now, my output here was curval and my carry, which will be used for the next math, the next addition. What do I do with curval? What do I do with this 2?
You add it to the end of the whole new huge integer, your answer.
Yeah, my answer. This guy becomes one of the digits in my answer, the last digit in my answer, correct? Now, we build huge integers using strings, correct? That's what we wrote our constructor for huge integers to do, is take a string as a parameter. So I'm just going to have a running total for my answer be a string, and we're going to concatenate cur value onto the end of it. So we're going to say string answer is equal to the empty string.
Wait, no, wouldn't we want our answer to be a huge integer?
It will be, because in the end, we will build a huge integer with that string.
Okay, yeah, just kidding, okay.
But yeah, you're right. Ultimately, add will return a true-to-life huge integer.
Okay.
We're just building it as a string first. We could write huge integer differently and say we're going to add digits to it as we go, but this works fine, correct? All right, so we have our answer here. And what are we going to do with our answer? We're going to say answer is equal to whatever answer is currently equal to concatenated with curval. But that'll actually build it backwards. Why? Well, if answer is currently a 2, the next time through will be curval should be a 1, right? We want the 1 to come before the 2, not after it. So as we have it written right now, we're taking whatever cur answer is or whatever answer is right now, and we're adding on to it curval. We really want to do the value first. So we're going to say answer is equal to curval concatenated with answer. Okay?
Start from backward.
Yeah, we'll build it backwards. So in the end, cur answer should hold 112. Then we'll use that string to build our huge integer. Okay, so that's what answer will do. Now, that's what we will do each time through. My shoe is falling off here. Okay. How many times do we want to do this? We know in our current little example, just to force the issue here.
3 times.
Well, we know it'll be once, twice, and then we'll have an extra little carry bit. Correct? For that extra little carry bit, since these values, these carryovers, cur pos at that point would be -1. Cur pos would be -1. Cur pos 1, cur pos 2 would both be -1. These are unusable spaces. So since they're both -1, we're not going to try to get the node at that position. We're just going to treat it as a 0. Does that make sense? That way we're always doing the same math. Okay? Now, when do we finally stop? We finally stop as soon as cur pos 1 and cur pos 2 are both less than 0. Then we know we're completely done. Does that make sense?
Mm-hmm.
But that very last time, we might have our carry bit. Okay? But each time through, for instance, if we had a number that was longer here, cur pos 1 would become less than 0 before cur pos 2 would. So anytime we're dealing with a position that is less than 0, we want to just treat the cur value at that position as 0, rather than the payload at whatever position it was, because that position does not exist. Okay. So right here is where we get our nodes. But before we get those nodes, we need to know if cur pos is equal to something legitimate. We'll get an exception if it's not, right? But we'd like to preempt that, since we don't want to try to extract a bucket -1 from this guy. So each time through, we're going to say node cur node. And actually, do we even need cur node 1 and cur node 2? Or do we just need the values?
We need 1.
The reason I ask is cur node 1.getPayload doesn't do anything for us. So we might say these are both integers. Int cur node 1, int cur node 2. Okay? So this guy would be .getPayload. This guy would be .getPayload. So then cur val would just be cur node 1 plus cur node 2 plus carry.
Mm-hmm.
That makes sense? Okay? But before, and this is going to have the exact same output as we just had before. Actually, I don't think I'm displaying anything right now, but that's fine. Okay, so it'll have the exact same output as we had before. We are just getting to it a little bit different way. But before I can go ahead and set cur node 1 and cur node 2 to something, I need to make sure that cur pos is a real value. Does that make sense? Well, not that it's a real value, that it's a legal value. That is, it's a value that's 0 or greater. If it's not a value that's 0 or greater, then we wouldn't just say cur node 1 is 0. It's a placeholder because the node doesn't exist.
The way you're doing it, does that mean we'd have to always make sure that we're adding the bigger number before the smaller number?
Nope. Shouldn't have to. No, because we're keeping track of cur pos for both of them. So if this number here has 1 extra digit on it, we'll run out of buckets up here before we run out of buckets down here.
Yeah.
So we'll just treat this guy as a 0. That's all we're doing. We're saying if the bucket doesn't exist, it's a 0. Because we know we can add 0 plus whatever, and it won't break anything. Right? All right, so up here, we're going to go ahead and initially define our cur node 1 and our cur node 2. Then we'll just give them values down here. Okay? Now, we're going to ask the question. If cur pos 1 is less than 0, then cur node 1 is equal to 0. Else, cur node 1 is equal to that. Make sense? Okay, so this makes sure that we don't try to get the payload of a non-existent node, because we're keeping track of where we are inside the list. Similarly, here we'll just steal that exact same code. Cur pos 2 is less than 0. Cur node 2 will be 0. Else, cur node 2 is HI number get cur pos 2 at payload and get the payload. Okay, so after both of these if statements, cur node and cur node 1 and cur node 2 both have a correct value in them. It's either the payload at that position or a 0 if that position did not exist. Okay? Which then says that this math will work. Worst case here is I'm adding a 0 plus the carry bit, which would be the situation here, correct? The way this math would work out. Eventually, cur pos 1 would be -1, cur pos 2 would be -1, assuming we're always subtracting 1 from it. We haven't added that into the code yet, but we will. So eventually, we'll run out of positions here, but we still have a carry bit. That make sense? So since we still have a carry bit, we'll take the carry bit plus this, and as long as it's greater than 0, we'll tack it on. Make sense? Because as soon as we get to a situation where cur val is always going to be the addition of this value plus this value plus this value. As soon as we get to a situation where cur val is 0, we are done. Not when cur pos 1 and cur pos 2 are less than 0. Because in this little example here, we still had one more little carry bit. Does that make sense? Now, we're going to have to do this math at least one time, correct? What kind of loop lends itself to something that has to happen at least once? 3 kinds of loops. While loops, for loops, do while loops. While loops lend themselves to problems where we do not know how many times we need to spin. For loops lend themselves to counting type problems. Do while loops. We know that if we're doing math, that our huge integers must have at least 1 digit in them, right? We will have to get cur value at least once. So all this crap here, all this stuff, all has to happen at least one time. So we're going to stick it all inside of a do while loop. So we're going to do all this while cur val is not equal to 0.
Okay.
That make sense?
Yep.
Let me just indent that real quick. Okay, so do all this stuff over and over and over again until cur val is not equal to 0. Now each time through though, we need to take cur pos 1 and cur pos 2 and subtract 1 from them. We initialize them up here. They started off at the last bucket of our linked list. And each time through, after we do all the math, we want to say cur_1 minus minus cur_2 minus minus. And once we run out of one of them, we might make a -1 become a -2, become a -3 or something like that. No big deal because they'll still be less than 0. Okay? So over and over and over again, we're going to take this number. Well, over and over again, we'll get cur node 1's value, cur node 2's value. It'll either be a 0 or an actual value. We'll add them together along with our carry bit. If cur val is greater than 9, our carry bit becomes 1. Cur val becomes this. What if it's not less than 9 or not greater than 9? That means we do not have a carry next time, correct?
Mm-hmm.
So we'll say carry is equal to 0. And cur val just stays as whatever is currently. So if cur val is 8, for example, well, we'll keep the 8. We're not going to do anything to it. We're not going to subtract 10 from it. But next time we will not have a carry. So we'll set our carry back to 0. Okay? Tack it onto our answer. Subtract 1 from cur_1, cur_2. Keep doing this over and over and over again until cur val is finally not equal to 0. Oh, keep going until it's finally equal to 0. So keep doing this as long as it's not equal to 0. When will it finally be equal to 0? In a situation like this, where the carry bit is 0 and we're off the end of both of our other numbers. 0 plus 0 plus 0 will be a 0. Now, we do have an issue there though. That very last time through, we did tack that 0 onto the front of our answer. Correct?
Yeah.
Right here. We only want to do this if cur val is not 0, right? Not necessarily true. What if the answer was 10? What if cur val was 10? Is 10 greater than 9?
Yes.
Yep. So carry will be 1. 10 minus 10 is 0. So I can't necessarily omit this, right? Sometimes I will have an answer of 0 for cur val. Row. So that's not really my stopping case, is it? What is my stopping case? How do I know I'm done?
When cur val is equal to
Well, I
Fine.
definitely need to have carry be 0, correct?
Yep.
I'm done when carry is 0. But not only when carry is 0. There's got to be more to it.
cur node
I'm done when carry is 0,
cur+1 and cur+2 should be minus
less than 0.
less than 0.
Yep, absolutely. So, keep doing this while carry let's see. Well, let's do it this way. Keep doing this while cur_1 is less than or is greater than or equal to 0, or cur_2 is greater than or equal to 0. While either of those are true, while I at least have some more digits to work with, keep doing this, right? Now, when this while loop is done, I might not quite be done. Because carry might have something in it, correct? As soon as I'm done with all my other numbers, though, I should be pretty much done with the math. So outside of this while loop, I should be able to ask the question, if carry is equal to 1, answer is equal to carry concatenated with answer. We'll go ahead and tack that on at the very end. Does that make sense? So at the very end here, answer should hold my answer. Let's prove that's the case. System.out.println answer. I know it's still a string. Go into driver. We have our 65, our 47. We'll add them together. There's our 112. Now we need to make that guy into the huge integer 112. So we will return a new huge integer built with answer. Otherwise, if something bad happened, we'll just return a null. Okay?
Hold up. I got a typo in mine and I don't know where it is.
Well, let's make sure this works first.
Yeah, I just tried it and mine adds up to 130.
Well, I want to make sure mine works first before I let you look at the code. All right. So we're going to say huge integer answer is equal to hi1 dot add hi2. Then we'll say answer dot display. And there's our 112. That makes sense? Now, what if this was 63 and 42? 105? What if this was 463 and 42? 505? 463 and 42. 4505? Let's make the bottom number the bigger one. So good? Okay. So I think that's a reasonable solution to the homework assignment. Now understand here, if we look at our code, I could have put all these things on one line, just defining a bunch of variables, right? So what did I do? I had to define 6 variables to make this work. 7 variables, I guess. So my first 7 lines here are all variable definitions. Then I have a little loop. 2 simple little if statements. Some addition. Another simple if statement. And then some concatenation with 2 decrements. That's the entire solution. All hard problems are made up of a bunch of easy parts. Does that make sense?
Mine's not working.
All right, so
When I'm watching, I'm stopping you a lot of time. I'm moving.
are you? Well, it's good. Now, as you were working on this, I already know the answer to it. You likely did not draw pictures as often as I did. Is that a true statement? Okay. Now, I've been doing this longer than any of you, and I'm drawing the pictures. So what makes you think you're going to pull it on? I keep harping on this, and I just cannot say this, how important it is about drawing these pictures. It will make your life so much easier. Okay? Dr. Locklear says this in all of his classes. Computer science is problem solving. IT is the same thing, right? IT, problem solving. How do we solve problems with computers? In order to solve a problem, you must first understand the problem you're solving. And if you didn't do this, you didn't understand the problem you were solving. You were just throwing darts and hoping you got the right answer. Make sense? Okay. And you said you got 133. Chances are you did not subtract 10 here.
No, I got 130 itself. I don't know where that came from.
All right. Questions about this?
Why we need to do this much job when we can use only one line of code?
Well, somebody had to write big integer, right? So yeah, you're only writing one line of code, but that's the beauty of encapsulation.
You want us to beg you for?
Well, I mean, the point is that somebody had to write that to begin with. Big integer's add method, I guarantee, is every bit as complex as this.
Okay.
Somebody wrote that. So you're just benefiting from it.
I'm just stop scrolling. No, I'm trying to read it and you keep scrolling and I can't read while you're scrolling.
So this is the good spot right here?
You know that really bothers me and I can't find where I messed up.
That's what's funny.
No, it's not though.
Well, to me, it sort of is.
You're wrong. This is literally the same. I do not understand.
Well, let's see that.
Are you passing at the same numbers here?
Yes. Not anymore, you just changed them, but I
What
was.
was it, 67 and
50,
was it 40 something? 40?
40.
What are my original numbers? Oh, here, I could check here. 65, 47.
Yes.
65, 47.
That's exactly what I'm doing. It is literally the same thing. I don't understand it.
Maybe you missed some
Well, it's definitely not literally the same thing.
in a note. Did you add that note? Get the
It is though.
Well, I'm not. I can scroll more. Tell me when you're.
Smaller.
It's pretty much all on the screen now.
We'll figure it out in a bit.
All right. So that's a reasonable solution to the homework assignment. Now, what if you did have to do multiplication?
Pretty similar.
How does multiplication work?
So we need to multiply from the end, like for example 7 to 5, and then have a bucket
Well,
again.
it's kind of a trick question I'm asking.
Because your bucket won't be now 1, so your bucket would be more than 1.
Let's say that I had the number 10 multiplied by 5.
So that way it would be
What is 10 multiplied by 5?
50.
50.
Yep.
Okay. How did you do this multiplication?
5 would be multiplied to 0.
Okay.
That bucket 0.
So that would give us the 0.
Yep.
So 5 times 0
It's bucket
is 0
0 and
with no carry.
no carry.
Okay. 5 times 1
would be 5.
would be 5. Okay. So that's our 50. All right. So now what if this was 55?
So now we
Now you have 2 levels, right? What if this was 555? 3 levels. If this was 5555. Not quite as easy as addition.
but still
Still a trick question.
now we need to change that what's the name? Carry not would be like 1, so this would be now more than 1.
Go ahead.
Wait, hold on.
So just so you guys kind of are fitting in the right world here, when I asked you initially to do addition and multiplication, the multiplication was supposed to seem way harder than it actually
No.
is.
Yeah, we can do like digits plus carry into digits plus carry.
No, it's
Go ahead.
I'm thinking it and it's simpler because it's what they're all saying. It's like you're taking the last one and then you multiply it, and then you just add it to the next one, multiply by that, and then make a 0 at the end of it.
Isn't 10 times 5 the same thing as adding 10 to itself 5 times?
Yeah.
But
So couldn't we implement multiplication using addition?
wouldn't that take longer?
We're already not high performance because of linked lists.
Oh, yeah.
But I mean, you're absolutely right. You're absolutely right from a, if we were really building this for performance, we probably would not do it that way. So I'll just say it out loud. We'll go and do it the interesting way here. So we'll be at least as high a performance as it possibly can be. But an interesting way to solve this will be to implement multiplication in terms of addition. We already wrote addition, right? So what do? We add 10 to itself. 10 plus 10 is what? 20?
20.
Well, our code, can I say 10 and 10 and get 20?
Mm-hmm.
Now, how do I know I'm not done? This 5 needs to become a 4. That 4 needs to become 3. Needs to become a 2. Needs to become a 1. Needs to become a 0. So the bottom number that I'm multiplying by, I need to keep whittling it down by 1, subtracting 1 from it. I don't need to implement all of subtraction. I just need to implement decrement, subtract 1. How would you do that? Let's say I wanted to write a method called, so this guy returned a huge integer. It's called decrement. And decrement should return a brand new huge integer that is 1 smaller than the current huge integer. Does that make sense? Now, our current implementation of huge integers does not support negative numbers, which is fine. So the smallest a huge integer can be is 0. Now, how would you implement decrement? I'm going to need to build a new string, right? So I'll start my answer off as the empty string. Now, let's say I currently have the answer 112. I'd like the new huge integer to be 111. How would I do that? If I wanted to take some number just say it's 47. And I want to subtract 1 from that to get 46. But remember, these are linked lists. These are already huge integers. How would I do that? Well, I'd start at the very end, right? And we already know how to get to the last pos. So I go to the very last pos of the number. Can I subtract 1 from this? Why? How do you know I can subtract 1 from this?
Greater than
Just
Because it's greater than 0. If it was equal to 0, then I would need to jump back a level. Does that make sense? Before I could do my subtraction. So since this is greater than 0, I can take whatever that number is and I can subtract 1 from it. Correct? And then say I'm done. But I still need to build my whole answer. How would I build up the rest of the answer?
Well, you know, you're supposed to do it if you get it's 0 and it's minus 1, then you have to go there. But you said we don't implement negative numbers in this thingy linked lists.
Yeah, we don't. Well, in our current implementation, we could make it work for like negative numbers. What would happen if we tried to add a negative 1 to our current big integer? Well, it doesn't work the way we've written it currently. Because the way we built our big integer,
Huge.
oh right, your huge integer, sorry, doesn't allow for a negative 1. But could I make a special case?
If you search subtract linked lists on Google, that's not going to work because we're building our own implementation.
not reading your computer, right?
What?
I mean,
We're using our own implementation. This is our
I'm
own
not-
code.
Well, right, he's looking for an example just to see how they might do it. Okay, so what if I tried to add a negative 1? Is there some way I can build my big integer using negative numbers? As I currently have it written, I can't. But this gives us an opportunity to look at static numbers. Right now, my huge integer takes in a string. But if I passed it in a string that looked like this, it's going to bomb out, right? Why? Because this for loop goes through and it goes through each individual character of this string. And the second it tries to convert a negative sign into a int, it's going to throw up, right? It's going to say this won't fly. Could I, though, figure out a way to create a huge integer using a negative 1?
First we subtract, then we return to negative 1.
Can I create a huge integer that has a linked list that literally has the one value in it at add end, and that value is a negative 1? Could I do this? Could I say static huge integer get neg1 could I say huge integer temp is equal to new huge integer and pass it the empty string? The empty string would leave my linked list as the empty list, wouldn't it? The number is a brand new linked list. How many times would this for loop go through? Remember, loops are pre-check. For loops are pre-check loops. If I pass in the empty string for num, how many times will this loop go through?
But we'll add the
No.
It'll be 0. 0 times. If my num value is the empty string has a length of 0. I starts off as 0. Is 0 less than 0? No, it won't even go through once. So by doing this, I could trick huge integer into being an empty number. And then I can say temp dot the number dot add end -1.
We'll add the empty string to the -1.
I haven't added anything. All I did here was take my huge integer and I put a -1 in the last bucket of its linked list, knowing that it only has one value in there. And I'll show you this. So then I'm going to return temp.
Like it will return to -1.
It'll just return the huge integer that holds a single value that's -1. Now understand this. I made this static. Static means it's a class method, right? How do we call class methods? Using the name of the class
Well, that's what I meant.
in which the method was defined. So I'm going to have to say huge integer dot get -1. So out here in driver, I'm going to say huge integer -1 is equal to huge integer dot get -1. And I'll say -1 dot display. Okay, I need to return null in here for just a moment, just so our code compiles. There's my linked list, -1. Does that make sense? Now, this isn't meant to be. This is a special case that we've built. Now, what would happen if I took, here, let's just steal that code. So there's our -1. We're going to say answer is hi1.add -1. So that'd be 10 plus a -1. Oh, it's going to break because of the 0 to begin with. If I had something like 16, we'll get the 15. But it doesn't work with the special case of something that ends in 0. So we can almost make this work pretty easily. We'd have to go in and write some more code, but we can reuse our add method to subtract 1 with probably a little bit of modification. Make sense? And what would that then allow us to do? It will allow us to do things like 10 times 5 by saying 10 plus 10 plus 10 plus 10 5 times. So we keep repurposing our add method over and over again for the same stuff. Okay? But let's go ahead and build this in a more interesting way, because we're going to actually have to use our own data structure in order to solve multiplication. We already saw that if we have the simple case 10 times 5. Oh. We know the answer should be 50, correct? Okay. And how did we solve this? We took 5 times 0, gave us the 0. The carry became a 5. Correct? Now, this placeholder right here, is this a 0? Or do I treat this as a 1? 1, well, if you did a 0, this would be 0 times 1 times 5, which would be 0.
There is no bucket anymore.
Correct, but even there wasn't in our addition either. In our addition, we decided we wanted to always stay consistent. We always had numbers. So when there's nothing here, multiplied by 1. Because 1 for multiplication breaks nothing. Any number times 1 is that any number, correct? So we would say 1 times 1 times 5 is 5. And since 5 is not greater than 9, we just put the 5 and we're done. Carry 0. Does that make sense? But what if we had 10 times 10? 0 times 0 is 0. Carry 0. 0 times 1 is 0. Carry the 0. 0 times 0 is, well, what just happened? 1 times 0 is 0. 1 times 1
1.
is our 1. Then add those two together. 0 plus 1, this is 100, right? Can we use our current addition model for doing this?
Yeah.
We could. So we need to build this multiplication. How many times are we going to have to do this? As many elements are in the bottom number. Correct? So in this case, we're going to have to go through and do all the math 2 times, or 3 times, or 4 times, depending on how big the bottom number is. Each time through, we're going to get an answer. And we're going to hold on to the answer because the next time through, we're going to get another answer. And what do we want to do? We want to add our answers together. Does that make sense? What if I had, here, let's just throw another number out here. Let's see, 10 times 110. Okay, so then on the next row down, we'd have what?
1.
1 times 0.
0.
1 times 1.
1.
And then add all those together.
1, 0, 0.
Let's steal this here. That's 1. That's 1. That's 0, 0.
How we can add 0 with the 0 to show up down there?
Okay, well, here's the question. If I took these two numbers, if I took those two numbers, and I added them together using our add method. So if I treat this as a big integer, a huge integer, and I treat this as a huge integer, and I add those two guys together, what would I get?
10. Because you're adding 3 0 with the 10.
But I want it to be
100.
100. What if I added it like that? Would that give me what I want?
Yep.
So each time let's just call this indenting. Every time I indent, don't I need to treat those like zeros? This plus this is 100. 100 plus 1,000 would give us 1,100. Could I call my addition over and over and over again as long as this guy was always padded out with zeros? So I can artificially pad out my result with zeros, correct? Okay, that's an important thing that we're going to have to do. That way we can keep a running total. Our initial answer is going to be 0. And then what will we do to that? Whatever we get this first time through, we'll add that to 0. So if I come in here, what we're going to do to our huge integer
Why do we have to make this static?
you don't have to make it static, but we only want this to exist once. We want the huge integer class to have a little function that allows us to just request the huge integer that is 0. Does that kind of make sense? You could have it be an instance, but really this is like a factory. We want just this one guy to be able to hand us zeros whenever we need a 0. Okay, and isn't the huge integer version of 0 just 0 like this? So we really don't even need this method. It was just our ability. It was a teaching opportunity to show you where a static method might fit into a class where a bunch of other methods are instance methods. Okay, but since this is just 0, this is how we create a huge integer of 0. So I'm going to go ahead and get rid of this method. We won't need it for our multiplication. We also won't need our decrement. So write public huge integer multiply huge integer hi. Okay, now we're always going to have a running total. That's our answer. Okay, but our answer is not going to be a string. It's going to be a huge integer because we're going to write this in terms of our add. So our initial huge integer will be the huge integer that is just 0. That's our initial answer. Okay? Initial answer will just be 0. Then we get our first value from doing our multiplication. 0 times 0, 0 times 0, or 0 times 1, blah, blah, blah. We get our first answer as a string. Okay? Then we build a huge integer out of that guy, and we add it to our huge integer up here. Out of curiosity, let me just return null real quick. What would we get out here if we did 0 plus 0, 0, 0, 0, or 0, 0, 0? Is this still a correct answer? It's represented a little funny, but it's still a correct answer, correct? All right. Now, if I took that answer and I added to it, we'd get the right answer. So if we did 0, 0, 0 and added to that guy 100, we would get our 100. Okay? So what I'm going to do to start off with here is we're going to start our multiply with a huge integer called answer, and this guy's going to be a new huge integer that starts off as the 0 integer. That's my base. I'm going to keep adding on to it each time, each level down we go. Okay? Now, again, remember, the very first time through, we just do our math. But the next time, we indent one. But in order to indent one, what do we need to do? We need to put a filler in here. So we're going to be building out a string. This guy right here will ultimately end up being a string. And the string we would have gotten is 1, 0. But we need to tack on to the end of it an extra 0. And then build our big integer out of that. Does that make sense? Because this is just how decimal works. This is the ones place. This is the tens place. This is the 100s place. This is the 1000s place. So we need to keep multiplying by 10 as we jump over. That's why we're indenting, so to speak. Okay? So how do we do our math? We take our bottom number only. So we're just going to have our Kerpos. We don't even need to think about, well, we do need to have Kerpos 1 and Kerpos 2. They'll both start at the end. Correct? So just like we did here, we'll have our carry. We'll have Kerpos 1 and Kerpos 2. All right. So Kerpos 1 will be this number, length. Kerpos 2 will be whatever number was passed in, his length. Now, for each number here, we're going to go through all the numbers up here to give us our answer. So what does that mean? That means if I have something that looks like this, for each guy here, I want to go through this and this. For this guy here, I want to go through this and this. For this guy here, I want to go through this and this. So I'm going to have to keep resetting Kerpos 1. That make sense? How many total times am I going to go through?
Much as that would be minus
3 times. This guy's length, number of times. I know how many times I need to do this, correct? I need to do it H1's length, the number of elements that are in that number. So we're going to write a little for loop for int I is equal to 0, I is less than hi dot the number dot length, I plus plus. That's the number of times we're going to have to do math. Each time through, what do? We reset Kerpos 1 to its starting point. For this guy, I'm going to go here, here. For this guy, I'm going to go here, here. For this guy, I'm going to go here, here. So each time through our for loop, we need to reset Kerpos 1 to be the last digit of that top number for us to actually do our math. Does that make sense? Okay. So that means initially, Kerpos 1 won't even have a value. Kerpos 2, we only set once, and then we walk backwards. Kerpos 1, each time, for each digit of Kerpos 2, we're going to have a Kerpos 1 reset. And then, what are we going to do? Then we're going to walk backwards on Kerpos. So each time through here, we're interested in this number, correct? We're interested in this node right here, its payload. So I want this 0. And I'm going to take that 0, and I'm going to multiply it by this. Then I'm going to take that 0, and I'm going to multiply it by this. So on and so forth. Okay? Giving me my answer and my carry. I don't care about this whole number down here. All I care about is this one node. So we're going to have int kernode 1, int kernode 2. And for I'm actually going to do this. It's the same math, but I'm going to do this a little differently just because we need to know where our last digit is and the one before that, the one before that. So rather than write this as a for loop, I'm going to say while Kerpos 2 is greater than or equal to 0. Do this. And at the end, we'll say Kerpos 2 minus minus. It will go through the same number of times. Okay, but I want to know where Kerpos 2 starts, and then I want it to become one smaller each time. Kerpos, this is 0, 1, 2. Kerpos 2 starts at 2. Then it goes to 1. Then it goes to 0. Does that make sense?
Mm-hmm.
So we're going to walk it backwards. So while...
Does this code work for whether Kerpos 2 is longer, or for the second huge integer is longer than the first two?
Yeah, it should.
And the first is longer than the second?
It should. Although we're always assuming, we're always doing the math the same way. So we won't look and see, oh, which of these numbers is bigger, let's multiply. We wouldn't flip it over. So we'll always just say, whatever this bottom one is, that's the number of times we're going through.
Oh yeah.
So things like 44,000, or things like 1 times 44,000 would be fairly inefficient.
Yeah.
Because we would literally go through the 45,000, those digits. So 5 times, multiplying everything by 1 to get 45,000. All right. So this loop will go through curpos greater than or equal to 0. Each time through, curpos 2 minus minus. What are we going to do? We're going to set curpos 1 to its current value. And we're going to say while curpos 1 is greater or equal to 0, do something curpos 1 minus minus. For each time through curpos 2, we'll go through all the curpos 1s. So when we're here, we're going to go here, here. When we're here, we're going to go here, here. So that inner while loop goes between these two. Okay? The outer while loop goes from this guy to this guy to this guy. Now I need to get my cur node 2. Cur node 2 is equal to hi dot the number dot get curpos 2 dot get payload. We'll go ahead and we'll do our whole try catch thing here. Okay. So cur node 2 will be equal to the current number. Inside here, we'll have cur node 1 will be equal to this dot the number dot get curpos 1 dot get payload. So the very first time through, cur node 2 in this little example would be equal to the integer 0. Cur node 1 would start off as the integer 0 and then go to the integer 1. So this guy will remain the integer 0 while this guy starts off as 0, then goes to 1 as we spin through this loop. Does that make sense how these two while loops are working together?
Mm-hmm. Much easier.
But hopefully you're starting to see why I didn't have you do this for your homework assignment. If addition was going to be hard, this actually won't be that difficult now that we have addition working. But there's some complexity in here that wouldn't have really been fair. You had a week, but you get what I'm saying.
Where are you putting the try? Like where's?
I just put it around everything.
Oh. Okay.
I could have also just said throw exception, but I went with the same mentality as we had with add. Don't inconvenience the person who's using this. All right, so what are we going to do inside this while loop? Cur node cur node 2, the very first time through, is going to be equal to this value, so it'll be our 0. Cur node 1 will be this 0. Okay? So we're going to take 0, this value, the value of cur node 2, and multiply it by the value of cur node 1. 0 times 1 gives us, 0 times 0. 0 times 0 gives us a what? A 0. Then cur node 1 goes to this 1. 0 times 1 gives us a what? 0. Are we done on this one?
Yep.
Okay.
And carry.
Actually, let me decide which direction we want to go. Do we want to go 0 times 0, 0 times 1, or do we want to go 0 times 0, 1 times 0, 1 times 0? Doesn't really matter. This is the way we did it first, right? So it would just look like that, right? All right. So 0 times 0 is 0. 0 times 1 is 0. That's our whole answer, correct? All right. Now we concatenate onto the front. So we have our working string. Yeah, so actually let's just call this let's call this huge integer answer we named up here. Let's just call this HI to return. That's going to be our final guy we're going to return. Okay? That way I can have my string answer that we used before for building up our answer for our big or for our huge integer. So each time through this outer loop, we're going to set answer equal to the empty string because we're going to be building up a brand new answer. And what are we going to do inside here? We're going to say answer is equal to, well, actually, let's do our individual numbers. What do we call it down here? We called it curval. So let's give ourselves an int curval here as well. We'll say curval is equal to what? It's going to be equal to cur node 1 times cur node 2. And actually, if we want to think about it, how we do the math here, cur node 2 times cur node 1. Okay? Cur node 2 times cur node 1. That's curval. All right? And then what are we going to do to curval? Well, let's just say this was a 9 and this was a 9. Kind of our worst case scenario. 9 times 9 is 81.
Mm-hmm.
So what is that?
1.
Carry the
Back 8.
the 8. Okay, how do we figure that out? How do I set my carries?
Carry won't be less than like more than 10. So it should be like 0 till 9. Can hold 0 to 9.
How did we get the 1 as our curval? By having an answer that's 81. If curval is currently 81, I want to have a carry of 8 and a curval of 1. Correct? How do I do that?
Just put the carry that we
How many times does 10 go into 81?
10 8
8 times. Remainder what?
1. Yeah, that's good.
Get it?
Yep.
So I can say this. I can say curval is equal to cur node 2 times cur node 1. Then I'm going to say carry is equal to curval
Times.
mod 10.
Okay.
Curval is equal to curval divided by 10. So let's say it was an 80. 80 mod 10 is a 0. $80 divided by 10 would be an 8. But these guys are flipped. I want my carry to take the 8. I want curval to be the 0. But you need to make sure you do this in the right order. So we're going to say carry is equal to curval divided by 10. We need to do this one first before we change curval. Then curval is equal to curval mod 10.
Okay.
Does that make sense? The order is important. Now, if we had something like 81, carry will be 81 divided by 10, which is an 8. Curval will be 81 mod 10, which is our 1. Okay? And then what are we going to do? We're going to take answer and say this guy is equal to curval concatenated with, curval concatenated with answer. Okay? Where does carry play in here? When we do our math, when we deal with our carry bit, is it multiplied or is it added? 9 times 9 is 81, right? So that's carry 8, and this is a 1 here. 9 times 1 is 9 plus the 8. So we add our carry bit. That make sense? Our carry bit started off as 0. When we do curval initially, it's going to be these two numbers multiplied plus our carry. And I didn't need to put the parentheses here because it would do order of operation, but just for clarity's sake, let's do the multiplication and then add on to that whatever the carry is. Okay? Does that make sense? This is very similar to what we did with the addition, where we're always doing the same math. Just so happens we started carry off at 0, so it wouldn't break it the very first time. Okay? So we'll always do this math, then we'll always adjust carry and, then we'll always set carry and adjust curval. We'll always add it onto our answer, and then we'll always curpos 1 minus, leaving curpos 2 alone. So the next time through, we'll still get cur node 2, which is already set. We'll have our new cur node 1, which is based on the new version of curpos 1. Okay? So we'll do that over and over and over again. When we're done with that, we have our answer. And what do we do with answer? As soon as this while loop's done, I need to take the current string that's in answer, and I need to do what with it? I need to add it to my HI to return. Does that make sense? So I'm going to say HI to return is equal to HI to return dot add new huge integer answer. So this guy right here will build for me a brand new huge integer built using answer. I didn't store it in a variable, but it's still the value. I passed it in to the add method for the current version of HI to return. And then whatever this does after it does the addition, I'll store the result back in HI to return. So we're ready for the next pass. That makes sense? Now, small little problem here. It's a tiny one. Answer is not always going to start off as the empty string. The first time here, answer was the empty string. The second time through, answer actually started off as a string containing a 0. Make sense? And we'll take our break here in a few minutes. I just want to kind of we're just about done with multiplication. So the very first time through, answer is the empty string. The next time through, answer is the string containing a single 0. The next time through, answer is the string containing 2 zeros. So we need to pad it out depending on which time we're currently through this guy. So what we'll do is we'll say int padding, start this off at 0. We'll start answer off as the empty string, but then we'll have a little for loop in here. For int I is equal to 0, I is less than padding, I plus plus. We'll say answer is equal to answer concatenated with a 0. Padding number of times. So the very first time padding is 0. So answer will just stay as the empty string. We won't get into this at all. The next time through, we'll add 1 to padding. So the next time through, padding will become a 1, which means we'll start answer off as the empty string, but then we'll put 1 extra 0 in it. Does that make sense?
Okay.
The next time through, we'll put 2 extra zeros in it. This allows us to keep doing, I don't know why I keep doing that. This allows us to keep doing our math. So the first time through, answer started off with nothing. Here, let's just get back to our 10 and our, that guy. So answer started off as nothing, and what did we get? We got 0 and 0, like this. The next time through, answer started off as nothing, but before we did anything else, we padded it with 1 0, because everything else is happening starting here. Does that make sense? So then we did the 1 times 0 is 0. The 1 times 1 is 1. See how that padding is working? That way, when we add these two numbers together, this is 100 plus 0, 0 instead of 10 plus 0, 0. Okay? The one thing we do need to be careful of, though, is each time through here, in our outer loop, we need to make sure we reset carry. So we're going to start carry off as being nothing up there, but we'll set it equal to carry equals to 0 in here.
Every time carry would be 0 if there is nothing.
Well,
like carry.
every single time we start, when we start with this digit, carry is nothing. When we go to this next digit here, we need to 0 carry back out because we don't want to be left over with our final carry from the previous time.
Okay.
Does that make sense? We don't want to have extra carries. We want carry to be a fresh, clean 0 each time through. So carry will start off at 0 for each of those bottom digits. Then it'll change inside of this while loop multiple times potentially. But we make sure we always 0 it back out when we move on. Okay? And each time through, high to return is equal to high to return dot add our new integer based on answer. When this outer loop is done, we'll return high to return. Else we'll return null. Make sense?
No, stop scrolling. Stop. I can't type as fast as you did.
Where am I? Is this good?
Give me a split sec. There.
Okay. So let's test this. So let's do out here in driver. So let's say we want to multiply 100 times 10. Oh. Oh.
Yep.
100 times 10 is 1,000?
Yep.
Let's do 134 times 12. Times 12. This should be 134 times 12 is 1608. 1608. 132 times 1234, or 134 times 1234, 134 times 1234 should be 165, 356. 165, 356. All right. So obviously based on our exhaustive testing, I think our multiply works perfectly. So that was the entire original homework assignment I've given you, but I think it was fair to leave multiply off. So again, just looking at this real quick, notice that multiply, again, all hard problems are made up of a bunch of easy parts. A lot of variable definition, 2 little while loops that just counted. One counted through 2, 1, 0, 1, 0. That's all it did. And if a for loop for padding, and a little bit of math. Nothing about this is difficult except putting it all together. And putting it all together like this really requires us to draw pictures. That makes sense? Okay. Questions, comments, concerns about that?
Try multiplying your original 2 digits, like the 65 and the 47 or something.
65 and 47? Should be 3055. That's weird.
Yeah, no, it's not regular.
There's got to be one special case here.
Well, what's that special case?
7 times 5. 65, 47. 47. Get rid of our carry bits here. So carry starts off at 0. 7 times 5 is
35.
35, so that should be
5.
5. With a carry of 3. 7 times 6 is 42, plus 3 is
5.
carry of 4. Okay, this is where it breaks. Because we walked off the end of these, right? If we have a carry left over.
Yeah.
So when we're done, if carry is anything but 0, what do?
We need to just put in that.
We need to drop it down. Okay, so that's going to be outside of here. If carry is greater than 0, then we're going to say answer is equal to carry concatenated with answer. Is that the right answer now? 3055? Yeah, we did the same exact thing inside of add, where we had to check to see about our carry bit. Carry bit in addition is always either 0 or 1. Multiplication could be bigger. Okay? Now, I'd like to say I did that on purpose, but I didn't. But punchline there is, and it seems like you learned something, we drew the picture. Do you see how easy it was for us to come up with the answer based on drawing the picture? Trivial, right? It's like, okay, wait a minute. We have this guy hanging out there. We're done with all these numbers. What the heck? We got to do something with them. That makes sense? All right. I think it works now. So we'll thank her for finding the bug and him for proving that he learned something. And me, obviously, for introducing the bug for a learning opportunity. All right, let's take let's take 17 minutes. So, well, we'll come back at what? I can't even do the math anymore. 35?
Yes.
35. 8:35. Come back. We're gonna start talking about steps.
Just count it and then.
Yeah, that would have been embarrassing. If you're having to do the on-screen calculator for math. That's how tired I am when I'm writing this stuff.
Yeah, I know.
You guys are at such a disadvantage here. Okay, let me